In this video, we are going to be discussing the exercise problem related to the chapter equilibrium. So it's basically class 11. We're talking about 6.27. Definitely let me know if you have a specific concept or an NCERT question that you need help with, and I will for sure try and help you with the same. So the equilibrium constant for the following reaction is 1.6 into 10 to the power 5 at 1024 Kelvin. H2 plus Br2 gives rise to 2 HBr, or is an equilibrium with 2 HBr. Find the equilibrium pressure of all the gases if 10.0 bar of HBr is introduced into a sealed container at the same temperature. So what they're trying to say over here is the fact that the temperature is constant. So let's start with writing down what they've given us. So the first thing they've given us is the equilibrium constant, which is 1.6 into 10 to the power 5. Okay, they've also given us the initial pressure of HBr. Okay, so they've given us the initial pressure of HBr, right? So the first thing we are going to do is try to use, and we need to find out the value of PHBr and PH2 and PBr2 at equilibrium. So the first thing we need to write down is the equation. So the equation is going to be 2HBr is in equilibrium with H2 plus Br2. Okay, so don't be confused when you see this particular thing where they've given us the equilibrium constant. But if you notice, they've also given us the initial pressure of HBr, which means it's the HBr that's getting introduced into this sealed container. So we are going to have to take the opposite of this equation. So automatically the equilibrium constant for this particular equation is going to be 1 divided by 1.6 into 10 to the power 5. Okay, because it's the backward reaction with respect to this. So the forward is 1.6 into 10 to the power 5. The backward would be 1 divided by that value. That's what we discussed, I don't know how long ago, but that's what we've discussed regarding the equilibrium constant. So the first thing we're going to do is write down the initial pressure, or the basically at initial point of this particular reaction, you have 10 as the pressure of HBr, right? And H2 and O2 would, H2 and Br2 would be equal to 0. And I know I've gotten too used to saying O2 after H2. At equilibrium, you would have 10 minus P, right? And P divided by 2 and P by 2 as the pressure for these two gases. So essentially what's happening is you have a deduction of the pressure of HBr by P, and then all of that would have split into H2 and Br2. So you have P by 2 and P by 2. So the P bar is the decrease of pressure of HBr. So the HBr is decreasing by P, right? So we are going to obviously have to write the equilibrium equation. So Kp would be equal to, first is going to be PH2 into PBr2 divided by PHBr square, because you have this 2, right? So this is equal to P by 2 into P divided by 2 whole divided by PHBr square. Now this is equal to the equilibrium constant, which is 1 divided by 1.6 into 10 to the power 5. Okay, so we're going to simplify this whole thing. So first of all, you have P by 2 square divided by PH, oh, PHBr whole square is equal to 1 divided by 16 into 10 to the power 4. Now, because I love to avoid, oh, actually, we should have just written it this way. I'm sorry. I don't know why I did not substitute that. Oh, well. 10 minus B and 10 minus p. So we can avoid the square symbol, and then you don't have to sit and solve for a quadratic equation. So what we're going to do is we're going to take a square root on both sides of the equation. So this will go away, this will go away, and then it'll be root over 16 into 10 to the power 4. So essentially, you get p by 2 divided by 10 minus p is equal to 1 divided by 4 into 10 to the power 2, or 10 square. So I'm just going to write this as p divided by 2 into 10 minus p is equal to 1 by 4 into 10 square. Okay, now we can switch them so they're on the numerator. So 4 into 10 square is equal to 20 minus 2p. So what we can do is 4 into 10 square is 100, right? Into p equals to 20 minus 2p. That's 400p equals to 20 minus p. So when you bring this over to this side, you will have to add. So it's 402p equal to 20, and p will be equal to 20 divided by 402. And this gives us a value of 0.0497 bar. So this is the value of P. Essentially what we've done is we've solved for P. Now that's not all. We have to find out the equilibrium pressure of all the gases. So at equilibrium, we know pH2 equals to PBr2, which is equal to P divided by 2. Right, so that will be equal to 0.0497 by 2, which is equal to 0.0248 bar. Okay, so that's what you get. Actually, it's 2485, so I'm just going to say 249 bar. And then you have PHBr is equal to the 10 minus P. So that's going to be 10 minus 0.0497. So this is equal to 9.503 bar. So that's it. So essentially, this is basically what we've been doing for a couple of example problems in the past. All we did was the most important thing over here is that we need to be clear as to which side is the direction of the reaction. They've done this just to mess with us. So you make sure that you write down the right value of the equilibrium constant. So for our equation, because we have the initial pressure given to us of HBr, we assume that this was the reaction, and so the equilibrium constant for this would be 1 by 1.6 into 10 to the power 5. That's a very important thing that you need to know. And basically all of this was just solving for P. We assume that there is a decrease in pressure of HBr by P, and that decrease in pressure is given is made up by P by 2 and P by 2 for H2 and Br2. And then we just solved for P and then figured out the values of PH2, Br2, and PHBr. That's it. I hope all of that made sense. In the next video, we will be discussing the common ion effect.